working from home with the robot on your desk, you don't want it to swing too fast, right? It's not an expensive robot, but it's still a problem if you break it. So,
but it's an expensive PC you got.
yeah.
Hey guys, welcome to Meta Toolbox, the video interview series where we try to save the world by solving one engineering challenge at a time. And we're in the final episode of our Let's Build a Robot series. And joining us again is Mihai Dragusu, who's a member of the technical staff at Wind River. How you doing, Mihai?
Hey, I'm good.
Good. So today we're going to be looking at the actual culmination of all the things we've been doing over the last 4 episodes in the operation of our intelligent robot. But first, let's just do a quick refresher. We were talking about OpenCV, the use of AI in our design. What are the actual models that we're going to be using for the object detection, etc.?
So for the object detection part, I picked up something very basic. It's called MobileNet SSD. You can get that from GitHub or various other places. I can share with you the exact page right now. So it's this one, right? And all I've done is download the MobileNet SSD model from there with this command, right? So I just got the MobileNet raw CAFE model MobileNet SSD part, and of course with this model you also need the proto.txt description file, and this comes also from the same repository. And what I've done is basically loaded that model in a Python script that has also ROS2. So I wanted to make the robot basically follow me around. So if the camera is pointed at me and I go to the left of the screen, I want the robot to turn left. If I do right, I wanted to do right. And because I wanted not to detect various other things in the room, I just took care of this and make sure that it can only recognize 2 objects, person and TV monitor, so we don't get too many stuff flying around. And that's also because working from home with the robot on your desk, you don't want it to swing too fast, right? It's not an expensive robot, but it's still a problem if you break it. So,
but it's an expensive PC you got.
Yeah. Yeah.
Very cool. So we're actually going to look at this in action. So what can you show us that based on everything that you've built? What have you got ready for us?
So I want to make this robot, I want to control it both with a gamepad connected to it. We've had various setups where you either get a remote, a wireless gamepad, and you can play with it. We have a setup where I wanted to avoid some objects and obstacles, basically reproduce something that I'm going to show you in a moment. What I want to do is basically reproduce a setup that we did last year for Embedded World, and it was this thing. So as you probably saw already, and we'll see, my robot is very tethered. I have a lot of cables going into it, but it can also be very wireless with a proper setup. And what we had it do in this demo, it was supposed to walk around this table and not hit the objects, right? At some point, it's going to hit the object, and that goes back to the question that you had on our previous episode. what redundancies can you build and what other things you can do to make sure that your AI deployment runs okay, is basically, in this case, it was to have good sensors, because this sensor is not the best one, and it can read stuff or not read them too well, and the robot can go into objects, not because of the software, but because of the sensor.
All right, that's great. So that's basically what we're trying to replicate here today, except not an embedded world and on your desk, right?
This is my entire setup. This is the whole space that I have in my house to run a robot, right? So we're not gonna be moving too much with it. I'm gonna try to put my hand and make it turn, and also have the setup where it turns while following me with the SSD model, the machine learning model. So picking up where we left off last time, we built our applications. What we have to do right now is just run them in our VxWorks environment. I usually connect to my VxWorks with Telnet. There are many other ways, but this is good enough for a fast development cycle, so I'm going to be using this one. And what we need to do right here to get the robot started, we just need to make sure that we have the proper library path, so that all the executables that we run go to the right place to pick up the libraries that it needs. And then it's better, let's see. Oh, by the way, when you're using VxWorks, if you want to delete something, it's Control H, right? Okay. It's not backspace, it's not delete, it's Control H. That's one fun thing to know. And the other one is, if you want to run the previous command, it's not up, it's Escape K, right? Those are the two weird things that you need to know.
Secrets from your adventures in VxWorks.
Yeah. And in order to do this, what we need to do is basically start a ROS2 node that connects to our board here underneath the Raspberry Pi, which connects to the motors that drive the robot. And in order to do that, you need to run this executable, which will come with the ROS2 build, right? And you want to point it to the serial connection. So the board, the OpenCR board that's connected to that's driving the motors, is connected to our Raspberry Pi using a serial port. And basically you need to tell that serial port, and also a configuration about the robot. This is the burger robot. There's also a waffle one. We're using the burger, so you need to tell it that configuration. And that's about it. We're gonna start this node. In a few seconds, it's gonna tell us that it connected to the OpenCR board. There's like an internal protocol that they use to get all this data. And now we have our robot node working. The other part that you need to do is also start a node that will publish data from the LiDAR that sits on top. So that's an add-on. It has its own node. You just start that also. Okay. So with that done, if your robot is connected to in the same network as your development setup, you should get in the Linux side of things, where you would have a ROS2 setup already done, you can see the topics. That's what they call them, basically what the robot publishes over the network. You could see them here. So this is done with basic ROS2 commands, and we're supposed to see this command velocity is the topic that we're going to use to send what the speed we want for the robot, and the scan is basically the topic that sends us the LiDAR information. These nodes are also available locally for the robot itself, and we're going to use them first, and then we're going to use the setup also to remote control it, because for ROS that's like that's why it's made. It's made to send things over a network, send the messages over a network, and have things like either separate control from actuation or have remote control setups like this one, so that helps you. Yeah, so let's first just start with controlling the robot using our keyboard from the Linux environment. Again, this the scripts that I'm using are mostly the teleop scripts that come with that come with the ROS2 demos. In most cases, some of them I've changed to have things like my own version of obstacle detection, but nothing more than that, right? So what we want to do is just go to the directory where we have what you do is run this, right? Oh, we hit an issue. It's not the right directory. Okay. Okay, we have a small problem here. Is it here? Yeah, it's here. Okay. Okay. And right now you can do is basically start typing D and the robot should turn. I've limited the speed to turn very slowly because I don't want to push it off my desk. And I hope that it's visible in the window.
Yep, we can see it moving.
Okay. That's great. So that's for the remote part of it. We can also control it from the local environment using a gamepad. So I have right here like a 360 Xbox 360 gamepad. It works with that. I've tried it with a few other gamepads, seems to work. I tried it with the PS4 one, and that one didn't work. So there's some work to be done from our gamepad driver colleague. Okay, so we plugged in the gamepad, but as I said in the last video, we don't have a gamepad driver in VxWorks. However, we've built one for this demo. So what you need to do is load that driver. I copied over on our SD card. It's in this location. This is the file. And what you do is just run this command, cld, and it's gonna load our DKM. And the next thing that we want to do is basically initialize the DKM because it doesn't have plug and play. And that's about it. Right now we have a gamepad compatible robot. The next thing that we want to do is control this robot and run one of the applications that we've built. When we run applications in VxWorks, we typically don't just run them as in Linux, just run the entire command. Sometimes we use this RTP exec. This is a tool that helps us increase the stack size for the executable because, as you know, VxWorks is meant for small footprint applications, and our setups are not at all small footprints, so we kind of force a bigger stack size for that. There are cases when we can run the application directly, and it's no big problem. This is for now is just a safety precaution, and we run it as you can see here. So, okay, run it again. It didn't. Okay, right now. Okay, there you go. So right now we have it. Okay, so let's try to snag our thing here. So right now we can basically play with the controller and move the robot. Right, it's quite sensitive. I don't think our application has some dead zone calibrations in there. So if I leave the stick, it still tries to read some values and move the robot. And here's the fun trick. If you have the remote script running on your Linux, you can basically stop it from there. So it's a safety measure. You can have that and stop the robot if it goes too well with your testing application, let's call it. And the other part that we can do is have this robot avoid. We run the command as before, but we run the void one, the one that we built. And this is gonna take input from the LiDAR and basically try to turn away from things that it has in A. So if I put my hand on this side, it's gonna try to turn on the other part, but it has an issue because it also is the monitor on that part. If I put my hand here, it has more room to turn, and it's gonna turn, right? If I put it here, okay. It turns in that direction. It's the same application that we saw it running on the table on Embedded World, but
on a smaller table.
Yeah, the budget version on my table.
Right.
Okay, so yeah, that's one of the cool things that you can do. There's also recently we had with the addition of Python in VxWorks, and the fact that ROS2 does run with Python, you can also do things like run Python scripts that call ROS2 commands. So this script is gonna try to read data from the LiDAR. Oh, okay. So as you can see, we get prints that are values from this. That don't try to understand it. It's just
Right.
an array of reads from the LiDAR. Yeah, and the last part, we're gonna use some machine learning with this robot, but as I said, we could use it on it. However, it's gonna be very slow. We don't want 2 frames per second, or even worse with our Raspberry Pi setup. So what we're gonna do is capture images and send them over to my machine, process them, and send commands back to the robot to turn. In order to do that, I'm going to connect a USB camera to our robot. And then last time we built the application for publishing images from the robot. What we can do now is basically run that. And we're gonna do that just as we did for the other parts. We're gonna execute this camera to image application that we built. Okay, so right now it's publishing images over the network. What we need to do is capture them on this part and process them, right? So let's see. We started this. Where is our frame? There it is. Okay, we have our second camera that's detecting a person, right? And what we want to do is have the robot turning when I'm at the extreme, so either the left side or the right side of the screen. I'm not gonna try to move too much because I don't want to ruin my setup here, but I'm gonna turn the camera. It's gonna basically do the same thing. And right now we have the robot. Oh, it lost me. Okay, there you go. Have the robot turning. We can do it the other way. And it turns the other way. And as you can see, we have fairly good frame per second here because it's running on my machine, not on the Raspberry Pi.
Very cool.
Okay, we can stop this. Of course, this is not a safety critical setup. Okay. You can try this at home.
Right. Not a safety critical setup. And another thing that we were talking about in previous episodes was the use of containers, but here we're not using any. Is that correct, Mihai?
Yeah.
But of course, when you are deploying this in a commercial setting, you're probably going to want to use containers. And there are a number of reasons for that. You're probably going to want to do some updates of your algorithms potentially, and then, just various updates in general. But it is completely possible to develop all of these applications that you just showed and put them in a container that's running on top of VxWorks and have it be safety critical. Is that correct?
Yes. Well, you can run it in a container. The containers for VxWorks are very simple in that case. And of course, it's a setup that you would do in production for various reasons that the container framework or advantages that the container framework setup provides you. One of them, especially for machine learning, is, well, it's actually two. One of them is if you process the information remotely, you want to have a setup that's both containerized and separate from your other applications, right? So that's one thing that that provides, and it kind of helps it. You could do it without, but the container setup helps you in that regard. And the other part is if you run a machine learning, if you actually deploy a machine learning model on the device, and you want to update that model because you've got better training data sets and it updated, and you want it to be more precise or things like that, or faster, right? You want to update that file. However, you want to make sure that the device gets that file from you and not from somewhere else. So the containerized setup helps in that regard. Again, you could do it. There are many ways to do this. This is one that we have found that's convenient, let's say.
Very good. Well, that was a great conclusion to our series. If people want to find out more about how they can take advantage of all the technology that we've used in this and the previous episodes, obviously there's a lot available on the various GitHub repositories, both from OpenCV and MobileNet and Wind River, of course. But how about training? Where should they go from the Wind River perspective to find out more, Mihai?
Well, for the Wind River perspective, we have various resources on the official website, and we have our deployment setups and labs.